started, thanks. Peter? Peter? It's like herding cats. Herding cats is easier. Okay, we'll get started. We've got a fairly full program this afternoon. First of all, 3 presentations, one from myself, next one's from Tamaj, and then we have Thomas Beale, who is absolutely one of the key brains behind the whole openEHR project. So it's great to have Tom with us. He's an old friend and colleague, and it'll be great to hear him update us on the latest set of specs, which a lot of people are very interested in, including myself. I've poked my nose into it, but it'll be good to hear a bit more. As I said at the start, I'm basically a clinician by background, but got myself into health informatics, health IT about 25 years ago. And I wasn't intending getting into data modeling. It was never part of my master plan. I was just a bit of a clinical hacker looking for data models to build some brilliant bit of UI, which never happened. But in that story, I fell into this strange world of openEHR. And it is, for those of you, I think a lot of people here have had some immersion or some understanding of what's happening, but it is quite a challenging area because it does kind of rip up the rules of how you build a system. And I think it was Wouter earlier hinted that one of the challenges we have is to say, look guys, we know you know how to build an application, but if you're a new entrant to this market, you almost certainly don't know how to build a health application that will scale. And there is this succession of keen, smart people who build an app and then they hit the buffers next time round. And so this is about starting to get people to understand how to do this right. And that can take a little longer to get up to speed, particularly as this challenges people's perceptions about how you do this sort of thing. So when I'm talking to clinicians, I kind of start from a kind of simple point, because there's a huge amount of, I was going to say ignorance, that's unfair. We do not train people to understand these concepts. One of the organizations I'm kind of headlining here is Interopen, which is a broad industry NHS group collaboration to advance the whole interoperability story in the UK. Still very much getting up to speed, but openEHR is definitely part of that. And we see this kind of approach as being perfectly legitimate as a way of getting data moving, about building systems faster and cheaper. And there was an Interop Summit that I'm sure some of you were at last year, and it was all about trying to teach not just CCIOs, but CIOs some of the basis of these things, because a lot of people don't come to it with a lot of knowledge. So, how do we think about what's inside an app? First of all, everybody knows there's a user interface, that's what you see and work with, and the vast majority of people understand that there's some kind of storage or database, might be a file, might be in the cloud, but there's some place that the data gets stored, and it probably has some kind of data model. People are used to playing with spreadsheets and kind of get the idea of data storage. What most people don't understand is the idea of an information model. That's a mysterious concept. There's this nebulous thing in the middle, which actually is what programmers generally are working with. It's what the applications talk to. And it's the logical or conceptual idea of the domain space. It's about the stuff of medicine in our case, or actually the stuff of health records. We have to be very clear. What we're trying to do in openEHR is not to model the biomedical domain. This isn't about fine-grained genomics. It's not about the physiology of the human body. It's about the documentation of clinical care. And that's a subtle difference. And often people get confused. This is about our working relationships with the patients and the data. Of course, it touches into that biomedical space. But much of the data that's in clinical records has nothing to do with biomedicine. It's times and dates. Who did what? Why did they do it? What were the other things going on at the time? And much of that is captured in information models. It's the working mental space of the application, which is then visualized through the application, the UI layer, and it's stored in quite often a completely different data structure in the database. So any definition of a structure or content of information that should be collected or shared. You can't see that, but the thing with the red border is a do not attempt pulmonary resuscitation form. That's a sort of information model. It's on paper, but it's telling me as a human being we want you to collect this information. It's applying some constraints to what I'm doing. I'm not allowed to put anything in there. I'm not supposed to. It's hinting me about what I should collect and hinting to me how I should collect it. But of course, we're talking in this context very largely about the digital version of the information model. So where do we see these information models? When people talk about minimal data sets for reporting, that's an information model. When we're talking about message or API interface definitions, we talked a little about FHIR and HL7v2. These are information models. But the critical thing that people often don't understand is that every single application has its own information model. That's how it works. It's the core bit of logic, if you like, that to which the whole app runs around. And fundamentally, sharing information between those different systems, different applications, requires us to share information models. That's pretty obvious. And that's where the fun starts. Because historically, for reasons that most of you will understand, we have worked in very siloed environments. I come from a GP background, and GP medication data, for historical legacy and actually some good sensible reasons, looks quite different from hospital medication data. That's all to do, well, it's partly to do with different clinicians and different developers figuring out what those models are. But it's also to do with the actual process of delivering medicine to the patient is fundamentally different. So there are some good reasons for that data, these data structures and data ideas being different, and there are some bad ones. Nevertheless, that is where we are. And we will not be able to get these systems to talk to each other unless we find a way of ironing out these differences. And typically what's happening at the moment is we're seeing essentially a bit of a collapse in the health IT market. You know, so when I started in general practice, there were probably like 20 GP systems. I'm not saying that many of them were very good. We're now down to effectively 4, you could argue 3 in the UK. And you can see that mimicked in the way that things are working with the big hospital vendor systems as well. You know, we basically have lost most of the big European EPR systems to the Americans. Now, I'm not being critical of those systems. They can do some very good things. But nevertheless, we have a problem where we have our health IT delivery is being concentrated in the hands of a smaller and smaller number of bigger and bigger systems. And that ain't healthy. And I think that's basic economics, that we do this sort of thing at our peril. Part of the reason for that is that doing this stuff is really very hard. Healthcare data, as Tomasz was saying in the morning, is incredibly complex. And those companies are effectively building their market share on their ability to handle that data, their ability to message it out to other places and integrate with the rest of the system. But of course, here's the 190 feral apps that Andy has, because the market finds a way. Oh, I keep doing that. No, you've seen it. The market finds a way. Clinicians are clever people, and if they're not clever people, they have clever mates who come out of university with a good computing degree. Oh, God. It's a Mac. It'll last for another half hour. It's no problem. I'll come back. I'll be fast. It says soon, yeah. All right. All right, so we have a problem. All right. I believe, and part of the openEHR story is that somehow we have to commoditize that. We have to commoditize that because we need this to be a much more vibrant market, make life simpler, easier for new entrants to the market. We heard that story before. And this is just my take, not as nice slides as Tomasz's, he does lovely slides, but it's the same idea. We got this idea of third-party apps. Thanks. We have a vendor-neutral information model. All right, so that's openIP, and that's in common. It's commons. And then at the bottom, we have a technology-neutral data store, CDR. So that's the ThinkEHR product that Mirand have. It's the EtherSys product that the Ripple guys are working with. And there are 3 or 4 other companies around the world. And we were out in China earlier in the year, and there are 2 or 3 Chinese companies building these systems as well. The whole idea is that you can swap these things in and out. All right? So We're working with a standard RESTful API in this query language Tamaj alluded to before. But you are not tied into a single vendor to give you your CDR product, right? Moran's a great company, great product. But great companies and great products don't last forever. Things change. And we have to be, we have longitudinal, lifelong data, as Tamaj says. We have to construct a market where we can get new entrants, we get smart apps at the top, lots and lots of value add from additional content like integrations to outside systems, but this idea of a technology-neutral data store. But it is all about building vendor-neutral content to support applications. And this, in some ways, this is the difference between the openEHR mission and something like the HL7 community, where HL7, its various varieties, is all about moving data between different apps and having a vendor-neutral data model, but between all these different systems as an interfacing model. We're putting that vendor-neutral model inside the systems and building a much tighter integration platform around that. As part of that, the other major problem we have is that getting healthcare standards has been historically almost impossible. It's dominated by people like me, right? The guy who's been in this for years, who stands up like meetings like this and pontificates about health informatics. We don't get the junior doctors. We don't get the nurses. We don't get the physios. We don't get the people working in social care. And they're the people who are working with these systems day in, day out. If we're going to get standards that are fit for purpose, we have to hear their voice. We also they have to take responsibility, because many of the challenges that we have in this health informatics space and the different information models are actually inflicted on the technical people by people like me. This is how I do allergies. I don't do it that way. I'm not going to do it that way. Now, the only way we can resolve our differences as clinicians is actually to negotiate and talk to each other. There are no true answers here, or very few, because we're in the area of culture and politics. We're not in the area of logic and biomedicine. So part of the core paradigm in openEHR is that it should be possible for stakeholders, by that I mean clinicians, patients, anyone else, to be able to define, with a little bit of help from people like me, to define those data standards and then plug them straight into this ecosystem without any re-engineering. And that's something we probably don't stress enough. People imagine, you build your data models, and then they go off to an engineer who figures out how to do it in a database, and they figure out how to do the UML diagrams. None of that happens in openEHR. We build the models as clinicians or clinical informaticians. We pump them into the CDRs, EtherSys or ThinkAir or OceanAir, and it works. We change them, it still works. That's hugely powerful. But of course, it lobs all the responsibility for mismatched information models back to us as clinicians. Technologists don't care. They just do what we give them. And if we give them dumb models that don't talk to each other, that's our problem. So there's a paradigm shift in this world around clinical thinking about asking clinicians to take responsibility for clinical information, which is quite hard. So we have some educating and we have some evangelizing to do to bring them into this world. But it is our world. People say, it's really technical. I've been involved in this medication work, and it is really hard, but it's not technical. It's detailed pharmacy. It's detailed, what do you do as a GP when you prescribe? How complex do the timings have to be? None of that is technical. It ends up being technical, but the hard stuff is the clinical stuff, and we need to get people involved in that. Not just building apps and saying, I want a nice colored button there and I want it to go ping there, but think about the information models, because you're going to have to share them. One way or another, this ecosystem will only live if you get data sharing. So, openEHR, to get onto the models. Two-level modeling. We've got this idea of archetypes, which is the core of the little clinical components, a blood pressure, an allergy, a procedure, a lab test, working hand in hand with terminology. There is, of course, sometimes there are choices about when to use terminology or not, but there is a sweet spot, I believe, where we can make maximal use of things like LOINC and SNOMED, and maximal use of the structural models that will take us a long, long way. We combine these together to form these templates that are much more like use cases. That's the sort of thing that would be sitting behind a dialogue on a screen, or maybe sitting behind an API or a message. But they're also based on a technical reference model that has low-level things like the quantity data type. So Kai this morning was asking about where's the units in that model of blood pressure. Where do the units go? The units are actually defined in the low-level data types. Not going to go into that in detail, but the message is that the reference model and the archetypes together build the information model. And the archetype, the reference model has the common kind of techie bits, low-level bits, that we generally try to hide away from clinicians so that you don't have to think about those lower-level tech bits too much. So this is the core, the archetype. Open source, they don't have to be, but this doesn't make sense if you don't make these things open source and shareable. Familiar components of a health record. And we have a philosophy that we call a maximal data set, which is bring it on. You know, if you think something is part of an allergy record, if you think something should be part of a blood pressure record, that's legitimate. We're not asking everybody to use mean arterial pressure or cuff size or some of these other obscure data points, but it's a way of sharing knowledge and understanding other people's perspectives, and saying, yeah, okay, it still is blood pressure, even though as a GP I will never use posture, and a way of getting those communities to develop. Then we got the idea of the templates, where we aggregate together these archetypes to build proper data models for a particular use case, and it's a key clinical endpoint. The template is the thing that we actually send up to the back-end systems. So we don't send individual archetypes as a rule. We send up these use cases, and that's our handover point from our clinician and clinical informatics world to the technical thing. They can also be used to generate class libraries, generate GUI. You know, different companies, including Morant, have built some really nice form builder products. You know, there's other work that we're doing as part of the Ripple project, exploiting the fact that these are technical artifacts can be used for all sorts of different purposes. So here's a situation where we think we've got a nicer version of the same slide than Moran did. All right, so archetype reuse, and I know where this I've seen the very original slide, but it's come through a few iterations since then. So we've got an app. It's a template for a diabetic clinic checkup. It's a handheld, maybe it's a patient thing, and it's based on a template is sitting behind that app. It's defining that data set for that app, but it's built up by bringing together a number of different archetypes. As we bring them together, we also constrain out or lose the data points that we don't lose. So in this case, probably, it's almost certainly, it's got blood pressure, but we don't need body site of blood pressure. We don't need the patient's posture. We don't need their exercise level. We just need systolic and diastolic. And we use the templating mechanism to strip these out so that they're not there for the clinician to cross-check, and they're not there for the implementer. You know, we take that out of their vision, and that makes the models a lot simpler to use in practice. But of course, the idea is that we can use those same models in a completely different clinical context. So in this case, a cardiology clinic. And the beauty of openEHR is that whilst these two, in a sense, are different documents, all of the data underneath that is completely cross-queryable. So if this is a single patient who's both at a diabetic checkup and a different clinic, we can still pull back their graph of blood pressures, even though it's been originally recorded using two different templates. So we've got an idea of storing data in a kind of documentary fashion, but pulling it back at much greater granularity and with complete freedom over the kind and shape of data that we pull back. And of course, it's app independent. The whole point about this is that we're not putting that logic, those clinical modeling ideas are not in the app itself. They're in the underlying archetypes. They're not even in the back-end data store. So you can take those models and move them elsewhere. Not only do you own the data, but you own the models. Very powerful. We've been using historically some tooling that's been on the go for many years. It's been time to move that on. I'm not going to talk about that in any detail, but we're pretty close now to having a new set of web-based tooling, which will be a nice springboard for some of the many new ideas we've been wanting to get implemented in this. Because having high-quality tooling for people like me to work with, for Wouter and his colleagues to work with, is really enabling in this space, and we can always do better. Just quickly to talk about health information standards. So So we're getting into, okay, we built these models, how do we share them, how do we govern them, who says they're any good? And I'll just leave that, I'm not going to go through in any detail, but I would say, sadly, and a lot of people, good people working on this, current national and international health information standards processes do not work. There's a top-down governance process, it's unresponsive, there are fixed review cycles. It doesn't work the way that modern software development works. We need to change that paradigm. Here's an example of the kind of work where we think we can contribute to the whole interoperability space. This is a respect form, which is the new version of that DNA CPR form that I talked about at the start. It's about patients' wishes. Changes about how we record patients' wishes about resuscitation have had to change in the UK. Some of you may be aware of the Liverpool care pathway scandal. There's a whole great public outcry, probably not entirely deserved. It was a bit of a political thing by the Daily Mail. Nevertheless, people within the profession, with the help of patients and other citizens, took a re-look at how we do that. Now they want to digitize this form. It's a paper form. And we're going to be working with them for country to come up with the archetypes and the templates that will underpin that. And that is largely going to be about dialogue, because different people come to this with different expectations of what it means to digitize the respect form. And we're just about to kick that off. To do that, we use a variety of tools. We use the tools that you've seen already to build these archetypes and templates, but we then need a way to socialize that. We need a way to reach out to the community of different stakeholders out there and say, what do you think of this? Have we got this right? We got it wrong. We know that there's a huge variation in the way that people think and use about data, and we know that we're going to have to ask people to compromise. How can we do that at scale? We can't do it by getting people into meetings like this. It's been tried, and it just doesn't work. So Ocean Informatics, one of the kind of early adopters of openEHR, in fact, largely pioneered many of the original technologies, have this tool called CKM. It's used in a number of countries in the world. And through the Aperta Foundation and a sort of collaboration of different organizations, including Ripple, we have a license to use this in the UK. And we use this to build the models, publish them, or at least publish them in draft form, and engage people in a proactive review process, get them to say what they think of this thing. This is a very specialized tool, probably only appropriate at kind of national, certainly a large regional level. And although it's a proprietary tool, all of the archetypes and templates inside it are open source and mapped out to GitHub. And that's something which, working in other disciplines, and I'm working in the fire community, we badly need something like this, because we need to get engagement from clinicians to tell us whether we're getting these models right. But this is the key to making this thing work. It's all about components. So that respect form, this is just a different view of that template. And what you're seeing there, the blue boxes are all those little different archetype components that we've built up. And some of them we've reused from previous iterations of the DNA CPR, because some bits of that have stayed the same. So we're not just ripping the whole thing up and starting again. We're actually trying to reuse as much as we can. And that's the sort of collaborative process that we've had, which is working very well internationally and starting to get going 5 countries in the UK. Coupled with that, we think we're not there yet in getting this over the line, but I think people are starting to understand that we need a different kind of governance. Evolutionary standardization with a lot of energy at the periphery and relatively light touch at the top. And those of you who understand open source development and open source governance methodology, this very much mimics it. And if you like, allows the market to express itself and say, this is the best model we can come up with. And as part of that, endorsement by august bodies like the PRSB or the Royal College of GPs, but not control. Right? They don't say this is good or bad. Well, they can say it's good or bad, but that doesn't stop the thing being published and potentially used. The market essentially will decide. Last but not least, people always say, how is this compared to fire? There's probably a whole day of discussion about that. All I would say is we can and do play very nicely with fire. See what I did there? So you're playing with fire. To the extent that we actually did a bit of joint modeling exercise. So if you look at the fire allergy and tolerance resource and you look at the equivalent openEHR archetype, they are 90% identical. And that's because we used that CKM tool to do that joint force. In other places, there's actually quite a lot of commonality anyway, so we don't need to worry about it. And the two things, openEHR, have quite different purposes, as Andy said this morning. And we can make these things work to everyone's benefit. I'm not going to say more about that. We can maybe ask it at the panel session later. We also have to and will play nicely with SNOMED. So this is not about saying we don't do SNOMED. Absolutely not. Whether it's SNOMED or LOINC, it is about using a combination of technologies to come together. So finally, this is a big paradigm shift. It pulls clinicians into outside of their comfort zone, outside of just thinking about the app on their desktop or on their phone, and into thinking about the information sitting behind that, because it is our clinical responsibility, I believe. It's not a technical activity. And if it's wrong, it's because we tell the technicians the wrong thing. And if we can't agree, it's because we can't agree, not because the technologies don't talk to each other. And it's not a science. It's not rocket science. And it is like herding cats. We just have to get good herding cat technologies and tools. Okay, thank you. I ask myself.
For you? Something difficult? No? They all know what you're going to say. Okay. Okay.
This hopefully will be a brilliant breakthrough. I'm tired of serving 50 years as a doctor, watching people lie over their teeth, saying, I have explained this operation, because that ain't true. And in Canada, you send the patient up, in gynecology, you send it up to the nurse, and she's got explanation stuff, and then she does with the consultation and the consent, and it makes so much more sense. We're stuck with all sorts of things because we don't think widely, and congratulations, this is a wonderful area. We've been waiting for years. You can't take an aspirin without a full official documentation. You can have a hysterectomy without any knowledge about the complications and the side effects.
Yeah.
That's disgraceful. So thank you very much for
We are at the start of a very interesting journey. A breakthrough moment for me in this whole space was I spent an entire morning in a coffee shop in Holland. Now, I should rephrase that, because this actually, I knew this was going to go wrong. I spent an entire morning in a cafe which served coffee with a colleague, Heather Leslie, who's kind of the queen of archetypes. And we spent 4 hours. And those of you who know Heather and I know we are pretty both sparky personalities. And we were almost at fisticuffs about how to model repeat prescriptions. And it was only at the end of that 4 hours when blood was, and we're both GPs, it was only at the end of that 4 hours where blood was on the verge of being spilt that we recognized that actually the way that repeat prescriptions are done in Australia, where she's from, and the way they're done in the UK are just different. And that's the problem. We don't understand that sometimes we do things differently because our situations are different. I can't remember.